Without further ado, I'm going to hand you over to Eoin Murray. I'll go off camera while Eoin's presenting. Eoin is Aquamonitric's head of research and development. He was massively involved in designing and producing the Aquamonitrix analyzer, and he's going to talk to us now about measuring nitrite and nitrate in activated sludge. So over to you, Eoin, and see you at the other side.
Thanks, Mike. That's great. So yeah, as Mike mentioned briefly, nitrous oxide emissions it's a potent greenhouse gas, but it has 300 times the greenhouse gas effect of carbon dioxide. And wastewater treatment is a significant contributor to nitrous oxide emissions globally. So it's clearly a growing and important area when considering climate change and savings in the form of carbon credits. As leaders and experts in the wastewater treatment space, a lot of you on the call or on the webinar now, you know and understand this. But within this presentation, we'll introduce a new in situ analyzer which delivers and makes available for the first time continuous, accurate nitrite and nitrate data across the wastewater treatment process. We believe this data provides wastewater treatment operators and managers a new avenue towards improved process control when considering nitrous oxide emissions and potential energy savings associated with the aeration process. In terms of the presentation, this is just a kind of an overview, a summary of what we'll look at. We'll look at how the analyzer works, the technology in which it's based upon, why nitrite monitoring, well, why nitrite and nitrate monitoring, in fact. Why does it add value, or how could it add value in these applications? And we'll look at some potential value points in which this real-time data can be used for. We'll look at potential energy reduction, potential greenhouse gas emissions in the form of nitrous oxide understanding and towards mitigation, and of course improved final effluent quality understanding by having in situ continuous nitrite and nitrate data within the final effluent. In terms of the analyzer technology and how it works, we'll touch on this very quickly, but essentially our systems and technology employ rapid ion chromatography with our patented UV LED-based detection system. And ultimately what that enables is simultaneous and selective detection of nitrate and nitrite in situ across essentially all water matrices, be it fresh water, all the way to highly polluted wastewaters, but it also has the potential to be used for brackish waters, fully saline. So a very unique range of matrices. In terms of accuracy, really it's for the first time lab quality accuracy delivered in the field or on site. We also have an accreditation, so an ISO 14034 associated with our analytical performance in the field, and this is specifically within the wastewater treatment and wastewater effluent space. So really to make it clear as to why our technology is different and how it overcomes the challenges which UV probes experience, it's all to do with selectivity enabled through the IC column and our UV LED detection system. So all UV devices must use algorithms and matrix-specific nitrite and matrix-specific calibration for nitrite and nitrate. They're the typical UV probes which are available and have been available for many years now. The key challenges associated with these probes, all to do really with interferences. So they're hindered by turbidity, organics, dissolved organic matter, salinity, of course, but really interferences are key with these measurements, and also fouling, of course, as well when considering the wastewater treatment application. If we quickly look at the absorption spectrum, when we're attempting to detect nitrite and nitrate selectively using these UV probes, it becomes a challenge because, of course, these two analytes overlap within that UV range. So algorithms need to be used, and it's not a direct measurement. How our system is different, we use, as mentioned, rapid ion chromatography combined with our UV LED-based detection system. And that allows for, as you can see from the chromatogram, which takes place within the system, we get resolved selective detection of nitrite and nitrate within even wastewaters and across all the sample matrices. If we look at the analytical range then, for nitrate, 0.6 all the way up to 500 milligrams per liter as NO3. For nitrite, 0.05 all the way up to 100 milligrams per liter as NO2. So a very broad range, and that opens up possibilities for the highly clean water, drinking water applications, but of course the highly polluted wastewater applications as well at those types of levels. So depending on the configuration and the application, you configure the system based on the application that's needed. Really just to kind of focus on the key points on how our system is different and how we're unique and how we add value. The system, as mentioned, ion separation. It's based on ion separation combined with our UV LED detection that enables selective nitrite-nitrate analysis. The calibration is never carried out on site. Our calibration of the analyzer takes place within our factory, and the system is simply deployed within the sample in which it's analyzing. No need to recalibrate on site. The fact that we have the separation also, it allows for high sensitivity measurement for nitrite, even in the presence of very high levels of nitrate, and vice versa, because we have that selectivity. A very unique aspect as well as the fact that the sample matrix independent. So the system can be deployed within a freshwater application. Levels, highly polluted levels can enter into that system. It doesn't need to be recalibrated. And also we've had some customers within the final effluent setting where there was an ingress of seawater, but the system, despite the system being deployed in a freshwater sample to begin with, even if salinity changes over time, there's no need to recalibrate the system. So that's a very unique value that our system brings. And then, of course, the drift and fouling question, that's typical of UV probes. Because we use the separation and we actually only introduce a very, very small volume of sample into our mobile phase for analysis, we don't experience the typical fouling or drift that would be common of UV probes. So if we look at the key processes, then this brings us on to how nitrite and nitrate data can add value when talking about the wastewater treatment applications, N2O emissions and energy and so on. If we look at the key processes in the nitrogen cycle, we can see the formation of nitrite arises as an intermediate along with its oxidation to nitrate. So it's clear nitrite has a role to play when considering nitrous oxide emission formation, and the emission, and it's a step on the important pathways. So we believe that accurate real-time continuous nitrite and nitrate data adds value when considering aeration and also advanced control in such systems as simultaneous nitrification and denitrification, also NMOX. And we also believe that by having this accurate continuous nitrite data, it opens up new process control opportunities for wastewater treatment operators. So to touch on some examples then on how the systems are being used within the wastewater treatment settings. If we're looking at, these are just some examples which we'll touch on briefly here, but for aeration monitoring, our customers tell us that nitrite is a risk indicator for N2O emissions. So they're using the real-time data to improve their understanding and control aeration to minimize nitrous oxide emissions. In addition to that, on the energy side, nitrite concentrations can potentially be used as an additional variable for real-time control. So this is a new area. We have a lot of collaborators and customers which are using the data towards this endeavor. A key point to note, of course, is to monitor the aeration tank sample, we need a sample pre-treatment step. So that can be typical commercially available membrane-based filter systems. We can connect our system into those typical systems. That's fine, and some customers prefer to do that. But we also have our own patented settler-based system, which it's easier in terms of maintenance, cleaning, and so on, and the challenges associated with the typical membrane-based filter systems, we believe we overcome them by using our settler monitoring system. Essentially, it's the system automatically pulls a sample in from the aeration tank. The system is the sample is allowed to settle. We then analyze the supernatant from that sample. So it's a nice clean sample directly from the aeration tank. Highlight some data. So this is typical data that we've taken from one of our sites in which the settler and the aqua monitoring system is deployed for monitoring an aeration tank. This is on our data monitoring platform, which is our custom IoT platform, which allows for remote access. But by having that settler system, it allows for this real-time data to be generated from the activated sludge process. And as mentioned, it's a reliable, clean supernatant coming from the aeration tank, and continuously remotely accessible data is enabled through our IoT platform. Bringing things to a close now, we just wanted to highlight an example of the real-time data that's being generated from a wastewater treatment facility in the UK. So this is, our analyzer systems have been installed here for 52 weeks. Continuous data have been generated. But if we look at the data which is being generated from the aeration tank, again, this real-time data hasn't been available up until now. All the chromatograms have been checked, so there's high confidence associated with the measurements. As we said, over 95% accuracy is what we expect from the analyzer. But some clear, interesting observations are coming through. Clear seasonal and diurnal variations are being observed. And really the key question now is, how do we use this information towards optimization? So that's what we're working with our commercial partners that are on the wastewater treatment side to determine this. If we take a more detailed look then on the diurnal patterns, so this data is during the month of September. So clear diurnal pattern is observed for nitrite. There's a nitrite and nitrate. The data is synced. Again, the question is, how can this data be used for optimization purposes? What's interesting then, if we look at the November data where the ambient temperature decreases, this pattern no longer is observed. And in addition to that, lower nitrite concentration levels are observed. And this would tie in with the literature in terms of the potential for nitrous oxide emission forming high temperature ambient versus low temperature. So again, this is an interesting data, but the key point is here, for the first time, this real-time accurate data has been made available through our analyzers. What are the next steps? Of course, we're looking for more commercial partners. We're doing a lot of work in the UK and looking towards Australia with some partners there as well. But of course, we're looking for commercial partners that we'd like to work with. In terms of data, spatial differences is another key consideration when looking at mitigation of nitrous oxide emissions. So multiple analyzers in a single lane, for example, correlating the nitrite and nitrate data with additional continuous parameters. So of course, ammonium is a key variable that would be valuable to be combined with these data sets, pH, DO, things like that. And then, of course, optimization and process control through real-time data. So to bridge that gap from the real-time data is available, feeding this data into automated process control, that's where we're aiming to get to. So I hope that was a quick run through. Of course, first, we'd like to thank you for joining us on the webinar. If there's any questions, feel free to ask at this point. But of course, we'd love for you to get in contact with us. If you'd like to have a more detailed conversation on anything we've discussed here, please feel free to get in touch. Mike, I have a poll here as well, which I might raise
Yep.
while
I was just
people
going, yeah,
are
I was
thinking
just going to say, if you can, put the poll up there. And the other thing I forgot to mention is there is a Q&A section at the bottom. So if anybody doesn't want to come on camera and give their question, please post them there. So there's just a poll while I just read some of the questions which we've already got in the Q&A. So again, multitasking, have a go at the poll. I've got a couple of questions here for or comments for Eoin. You talked about the size of the sample being very small. And somebody just wants to know, so what sort of dilution ratio do we have when we take our sample? You talked about getting it into solution. If you could just elaborate on that and explain how the dilution helps with fouling and things like that.
Yeah, no, it's a very important point, Mike. So we didn't go into it in detail within the talk, but our fluidic system on the sample, our sample inlet and outlet are submerged within the sample matrix which we're analyzing. We have a small pump in the system which draws the sample through the analyzer, looping it essentially. But there's a reservoir within our system. We then pull an aliquot from that reservoir, which contains a homogeneous representative sample. So we're actually we're only pulling 800 microliters into the system, but we're only actually introducing 10 microliters into the mobile phase. So the mobile phase total volume of 3.3 mils and a sample volume of 10 microliters to give you an idea of the type of dilution. And of course, we're passing everything through an anion exchange column, which is full of particles. So the typical fouling challenges associated with probes and things don't come into play for us.
Okay. We've got a couple of questions coming through now. I'll just so we've got one question on the Q&A, which we will come to in a second. The other thing which you talked about was the way the settler looks at the supernatant, and somebody's asking, in terms of how does that make the analyzer more accurate? If you could talk about the way maybe, the lab, the delay in getting a sample to the lab over a couple of hours can affect the sample, and so and I think the question is about how quickly do we get our number, and how does that affect the accuracy and precision of the reading?
Yeah, so the challenges and issues associated with grab samples, I think they're very well understood, but especially when considering nitrite and nitrate measurements, and in wastewater, the highly biological nature of the samples. Nitrite and nitrate are both labile species. They're converting, they're changing, and we've done extensive studies on this as well. And even in the river water setting, the same thing applies. But within the space of a couple of hours, your nitrate and nitrite are changing substantially, significantly. The settler system, within 15 minutes, 10 to 15 minutes, we've pulled the sample, we've analyzed the sample and generated the data point. Within that time frame, no significant change has occurred on the nitrite or nitrate species.
Yeah, I think it probably helps that we're taking away that biomass as well, because if the biomass isn't there, that's going to slow the chemistry down as well.
Yeah, good point. Yeah, absolutely.
And then we've got a question from an anonymous attendee, which is around: have we had any experience at monitoring in the anoxic zones yet, just to understand maybe how this could be used to control RAS, return activated sludge rates? I don't think we have, but so the answer to that is no. I don't see why we couldn't do that at the moment. We do have a pilot about to start with a major UK water utility, where we are going to be doing this spatial separation. So we're going to be doing beginning, middle, and end of an activated sludge process, and one of the analyzers will be in the anoxic zone to do exactly what you're talking about. So I'm sure the pilot will be producing data, and there'll be updates. So please join us on another webinar in about maybe 2 or 3 months' time, where we're presenting different results. Well, just before we take Steve Bungey's question, here are the results, which is interesting. Dissolved oxygen, not a great surprise, 90% of the votes, but ammonia, that fits in with what we would find. But the nitrous oxide gas, that's interesting. So 20% of people are now looking at that. nitrate and nitrite. So there are already people looking at it, which is good news and very interesting. And we'd certainly like to help you do that. Let's just have a quick look at some more of the questions. So this is an interesting question, and Steve, we thank you very much for the question. It's what process intervention would you take if nitrite concentrations are rising? Now, as Eoin said at the beginning, we are very, very confident that we can produce the numbers. We're not process chemists. So the intervention is something we're trying to find out what is the intervention. And we can speculate about it, but the pilots that we're doing are going to make interventions and see what happens. So, intuitively, as a chemist, you might want to prevent nitrite accumulating, and the only way you're going to prevent it accumulating is to force it down the nitrate pathway, maybe. So you might turn the oxygen up, which might be counterintuitive, just to get the nitrite down. And that would certainly be a first step that I might take as a chemist. I might think, okay, the chemistry is there. Let's give it a bit more oxygen, force it down that pathway. There might be other ways. You might reduce the ammonia feed coming in. So there are things which could be tried to optimize it, but right now, as I said, we're sort of in the foothills of this mountain, exploring control possibilities. So that's it. And Steve, here again, an interesting comment. Okay. So again, yes, it's basically, Steve, they're confirming what I was saying. You dynamically change the dissolved oxygen set point to drive nitrite to nitrate, and that's something which, as I said, as a chemist and somebody who's worked in wastewater, that would be my first attempt at optimizing this process. To answer. Again, there's a question here coming in from Fauzi, and just for everybody, yes, the webinars, thank you for saying they're valuable, informative. They will be available as recordings to everybody who's registered to answer that one. This is one for you, Eoin. We've got a question around suspended solids levels. And the question is, what's the minimum? Is there a minimum suspended solids level recommended? And then tied into that question from Sarah is, what is the longevity of the ion chromatography column, which is probably to do with the pre-treatment, but I'll let you answer that one.
Yeah, so on the suspended solids question, the only application or sample in which we need a kind of the additional pre-treatment step is the aeration tank. Of course, for obvious reasons, it's a different type of sample. But for final effluents, the system can be deployed directly into the sample, final effluent sample, because final effluents are so diverse and varied. A difficult question to answer, but typically it comes down to the system can be deployed directly. The results will be fine. We have a prognostics system inbuilt into the analyzer, which indicates if buildup of suspended solids is happening on the intake system. We know ahead of time, so we can proactively predict maintenance and so on. And in terms of maintenance, what's needed is just a flush of the intake system. So the suspended solids, typically, it doesn't have an impact on the actual analytical measurement, but sometimes, especially on final effluents and challenging high suspended solid samples, you can get a build up on your intake lines. So it's just a case of flushing them in terms of maintenance. In terms of column longevity, they've been absolutely, in pretty incredible in terms of how long they last. But again, that depends on the application. The drinking water application, you're talking 6,000, 7,000 runs. A wastewater final effluent, we would recommend potentially 2,000 to 4,000. But again, that could be plus or minus on either side, depending on the composition of the final effluent. But again, it's not something we have visibility of it, and you as an operator or customer as well, you have the real-time visibility as to how things are looking from the chromatography point of view. So that informs a lot in terms of planning your maintenance and so on. You're on mute there, Mike.
The famous "you are on mute." My goodness, how many times? And that just again to drill down on that for you, Sarah, in terms of the longevity, and Owen's talked about runs there. So if you had a duty cycle on an activated sludge plant where you were taking a reading every 15 minutes, which would be more than most people do, but you can do that every 15 minutes, a nitrite number. That would equate to doing something to the column on the worst case scenario about every 2 months. But just to point out as well that the ion chromatography column is a refurbishable, it can be regenerated. So although it is a consumable, what most end users would do is they'd have a standby column. It's not a high expense item. Replace the columns, which is quite simple. It's a push fit connection. Put the new column in, regenerate the column for the next run. So it's a relatively straightforward operation and not a high cost operation either. So activated sludge, worst case scenario, change the column once every couple of months. But as Eoin said, that as we're doing more and more of these, the envelope is pushing out further and further, and we're pretty confident we're going to be into the 3 to 6 months period, because the settler system really does produce a solids free, really nice sample, and it's really solids that cause the problem, and by settling them rather than filtering them, we take a lot of them out. So I am conscious of everybody's time. We're up to the final minute now. We've had a lot of questions there. What we will be doing is all the questions we've had raised will be answered by myself and Eoin and other members of the team, and they'll be circulated as an email document to everybody. Once again, thanks to everybody for attending. There have been some great questions there. Watch this space. We will be representing our new data probably on a 3 to 4 month timescale as the pilots start to kick in and we start to get further up this up the mountain of understanding. But that's about it for today. All it is just to say thank you very much to Eoin for the presentation, very informative. Thank you for Richard in the background for making it all happen, and John for keeping us all sane and making sure we'll get everything done on time. So that's it from us. I just said that. I think there's another question just popped in. 1 second. Just if everybody's got time, Alec Kimball. In terms of installation, the quickest I've ever done one is 15 minutes on a lift and shift. I arrived on a wastewater treatment plant and we had data going to the cloud in 15 minutes. That was about as quick as it could ever be done. And yes, there are 2 versions of the product, Alec. It can be moved between sites, and that's something we do routinely. If a client wants some quick data and just wants 2 days worth of data to do a survey or just get a handle on a process, absolutely, definitely it can be moved. The process control version is intended to be installed in a kiosk on the aeration lane, producing data 24/7. And thank you for your comments about the insightful presentation. Nice to know it's gone down well. And thank you everybody for hanging around. A couple of minutes over time, so I do value everybody's time. And that's it from us. See you next time. Thank you for attendance, and thank you everybody.